Good morning, students. Physics, Chapter 1, Physical World. Yes, Chapter 1 is actually one introductory chapter. Okay, in this chapter, if you read textbook, okay, you will get yes, it's all about questions and what we will study in 11 and 12. Okay, physics, yes, physics means study of nature. Okay, yes, if you observe things around you, then yes, the study of this each and everything, it is called physics. Okay, so yes, in physics there are numbers of concept, numbers of phenomena, numbers of law, okay, numbers of hypotheses that you will study in 11th and 12th. Among this, okay, force is one important physical quantity. Force, what do you mean by force? Okay, if I want to displace any book, then obviously you will say, yes sir, you have to apply some force. If you want to push any vehicle, okay, then yes, you will say, yes sir, you have to apply some force. You also know some different names of forces. Frictional force, normal force, tension, intermolecular forces, interatomic forces, gravitational force, electric force, magnetic force. Okay, so these all types of forces are there in nature, but among this there are some forces which are in fundamental, which are in base of physics. Okay, and they are called fundamental forces. Fundamental forces in nature means in nature you will see at basic level these all four forces. So yes, in this lecture we will see fundamental forces in nature. So yes, title is fundamental forces in nature. First force in nature, that is gravitational force, because yes, you know about gravity from your childhood. Okay, gravitational force, yes, if you drop this chalk is moving towards center of earth, we know gravity. Okay, apple is falling down from a tree, gravity. Yes, we know concept of gravity. So yes, what is gravitational force? First of all, let me make one thing clear. Okay, in this lecture, yes, there are some concept, that is electrical force, magnetic force, okay, that you might not understand, but after 11 and 12 you can easily understand this each and every topic. Okay, it is just overview that we will study in 12. Okay, so yes, first force is gravitational force. This gravitational force we will study in 11th in chapter number 8. In 11th, in chapter number 8. What about gravitational force? Yes, you have to remember some points. First, force of mutual attraction between two objects by virtue of its mass. By virtue of its mass. Yes, we know that. Okay, gravitational force is acting due to mass. Earth, it behaves as one sphere, okay, a very large sphere. So due to earth, on each and every object, gravitational force is acting. Gravitational force is acting. So yes, you know about gravitational force. It is universal force. What do you mean by universal force? It is acting at each and every place in this universe. Okay, if two objects are within this in this universe, then on each and every object this force is acting. On each and every object this force is acting. Every object experiences this force due to every other object. Yes, we know examples. Okay, each and every object lying on earth experiences force of gravity due to earth. Similarly, in solar system, each and every planet in our solar system actually, okay, in our solar system, each and every planet experiences gravitational force due to sun. So see, if if you observe this all concept, this all phenomena, okay, Earth is revolving around sun, moon and satellites are revolving around the Earth. So these all phenomena, they are due to gravitational force. They are due to gravitational force. Clear about this? Okay, so see, all objects on Earth experience force of gravity due to Earth. It plays a key role in large-scale phenomena of universe. It is long-range force. What do you mean by long-range force? Yes, there are two types of forces: long-range force and short-range force. Long-range force means it is acting at large distance. It acts at large distance, while for short-range force it is acting within some length, okay, not at large distance. So it is meaning of long range force and short range force. Long range acting for long distance, short range acting up to some specific region by nearby. Okay. So yes, it is all about gravitational force. You have to remember these points. Okay. One extra point, that is force between two masses given by Newton, that is F is equal to Fg is equal to, it is G m1 m2 upon r square. Gravitational force is directly proportional to product of their masses and inversely proportional to square of distance between them. Okay, so yes, these things you have to remember. Some key points, that is, it is always attractive, it is due to mass, it is universal force, it is long range force, an equation of gravitational force. Clear about this? Okay. In physics, we will see three types of field. Okay, gravitational field, electric field and magnetic field. Gravitational field, it produces due to mass. Yes, gravitational field, it produces due to mass. Earth, okay, we know that Earth, it behaves as a sphere. So due to mass of Earth, it produces some effect around it called gravitational field. And as we all are in this gravitational field, we experience some force. If we are outside this field, no force is acting due to Earth. Okay, so yes, it's all about gravitational force. Okay, detailed chapter number 8 in 11. Clear about this? Okay, chalo. Now next one, second fundamental force. Second fundamental force is electromagnetic force. Electromagnetic force means what? See, if I say property of any matter, then yes, you can say it's mass. Okay, due to mass, gravitational forces acting. So similarly, okay, any matter is made up of yes, particles are made up of. So yes, they are made up of molecules are made up of atom is made up of proton, neutron, electron, fundamental particles. And these fundamental particles have mass as well as another property, that is electric charge. And due to this electric charge, another two types of fields are produced. Okay, electric field and magnetic field. See how? Force between charged particles. Electromagnetic force is force between charged particles. Means if on two particles, okay, they are charged particles, then force is acting between them. Electrical force is acting between them. No charge, no electric force. Clear about this? No charge, no electric force. So as these gravitational forces acting by virtue of masses, this electromagnetic forces acting by virtue of charge, electric charge. by virtue of electric charge. Okay. If charges are at rest, stationary charges, then according to Coulomb's law, force is acting between them. Similarly, like this. Okay, if we have two charges, Q1 and Q2 separated by distance r, then electrical force acting between them, that is Fe, is equal to, it is K Q1 Q2 upon r square. Fe is equal to K Q1 Q2 upon r square. Okay, so yes, if charges are at rest, stationary, then according to Coulomb's law, force acting between them is Fe is equal to K Q1 Q2 upon r square. Yes, between two unlike charges there is attractive force, between two like charges there is repulsive force, that you know. Okay, so yes, it is when charges are at rest, and these charges at rest, they produces electric field. Okay, so when charges are rest, we can say they produces electric field. But when charges are in motion, when they are in motion, they produces some magnetic effect. Charges in motion produces magnetic effect, and magnetic field gives rise to force on charges. Okay, so yes, stationary charges produces electric field, charges in motion produces magnetic field. Okay, and see about this, that is electromagnetic force, what is electric field, what is magnetic field, that we will see in 12th. Yes, that we will see in 12th. About electric field, we will see two chapters. Okay, first two chapters, they are mainly known as electrostatics, then current electricity, and then chapter number 4 and 5, they are about magnetism. In 12th, they are about magnetism. Basically, part 1 of 12, it's all about electromagnet. Okay, so yes, this whole concept in detail you will study in 12th. Okay, so next point. See, yes, I said in 12th, first 8 chapters, that is your part 1, we will see electric field, magnetic field, and we will also come to some conclusion. Okay, due to electric field, magnetic field is produced. Due to magnetic field, electric field is produced. Means they are not separate branches. But they are related to each other, and that's why they are known as electromagnetic. Okay, so see, magnetic effects, they are inseparable, and hence this force is called electromagnetic force. Remember this point. Okay, next point. X over large distance. Large distance means long range force. It is long range force. Okay, it is strong compared to gravity. Yes, it is one important point. Okay, electromagnetic force is very, very strong than gravitational force. And see, it is equation of gravitational force, it is equation of electric force. Okay, in 12th we will prove. Okay, if you are given two protons, suppose at distance 1 centimeter, we know mass of proton. Yes, we know mass of proton, that is 1.67 into 10 raised to minus 27. Okay, so with the help of this equation, we can easily find what is gravitational force acting between two protons. Yes. Similarly, we know charge on proton. So with the help of this equation, we can find what is electric force between them. And if we compare these two forces, then you will get one result, that electric force, Fe means electric force between two protons is 10⁻36 times greater than gravitational force for any fixed distance. Yes. Okay. If we have two protons, for example, at 1 centimeter, then gravitational force and electric force, if you compare this force, then you will get result. Okay, electric force is 10⁻36 times greater, 10⁻36 times greater than Fg. That is gravitational force, 10⁻36 times. Okay, so yes, we can say electromagnetic force is very larger than gravitational force. Clear? Okay. Matter, I say yes, matter is made up of, okay, yes, particles are made up of molecules are made up of atoms are made up of electron, proton and neutron. Out of electron, proton and neutron, electron, charge particle, proton, charge particle, neutron, chargeless. Yes, neutron, chargeless. Okay, so matter, elementary charge particles, electron and proton, and see, this information is for electrons and protons, means for very small particles. Okay, if very small particles, for very small particles, if you get a relation like this, okay, electric force is greater than gravitational force 10⁻36 times, then see, as it is very greater than gravitational force, electromagnetic force governs the structure of atom and molecules. What is meaning of this statement? Governs atoms, structure of atoms and molecules means forces between atoms, forces between molecules, you can consider they are due to electromagnetic forces. Okay, next, gravitational forces, attractive force means mass has only one variety. Mass we are always considering positive. Mass is always positive, but electromagnetic force, it is attractive or repulsive. Attractive or repulsive means there are two types of forces, means there are two types of charges, variety of charges too, positive, negative. Yes, we are taking charge on electron negative and charge on proton positive. Okay, so yes, it is difference between gravitational force and electromagnetic force. Any matter, it is electrically neutral. Now, electrically neutral means total charge is equal to 0 on that matter, on that object. Okay, electrically neutral, it does not mean that there are no charges. There are no charges, it does not mean, okay, yes, it has charges, but number of positive charge is equal to number of negative charge, so total charge 0, means it is called electrically neutral. So matter is electrically neutral, so electric force is 0, and if electric force is 0, then gravitational force dominates terrestrial phenomena. It means, see, I will give you one example. You know that, okay, chapter number 5, laws of motion, we have discussed one topic, that is, see, here I will write, if it is sun, or suppose it is earth, okay, around earth, planet or satellite, or we can say it is moon is revolving, then in this case, for circular motion of moon, circular motion of satellite, required centripetal force, required centripetal force. In this case, okay, it is provided by gravitational force. It is provided by gravitational force between earth and moon, okay. So for terrestrial phenomenon, we can say that governing forces are gravitational force. In case of, if it is nucleus, and electron is revolving around it, then for circular motion of electron, required centripetal force is provided by electric force. Is provided by electric force. This Coulombian force. This Coulombian force. Clear about this? So yes, it is difference. See, it is difference. Large scale phenomenon. Large scale phenomenon. And it is related to elementary particles. Clear about this? Okay, so in large scale phenomena, yes, gravitational force, governing force. While in case of very small charged particles, okay, that is structure of atom and molecules, electromagnetic force is governing force. Clear about this? So yes, you have to remember this difference. Okay, now last one, means last point of this force. If you have book in your hand, okay, if you have book in your hand, then yes, you can say that this book is stationary. Okay, what happens actually? For example, it is book, it is in hand. Then weight of this book, it is acting in downward direction. Weight of this book is acting in vertically downward direction. That is nothing but gravitational force. So this W is nothing but gravitational force. Okay, but see, this book, hello, I assume it is book, okay. This book is stationary. Stationary means resultant force becomes zero. Resultant force becomes zero means due to this book, force is acting on hand, and due to hand, force is acting in upward direction. That is nothing but normal force. Yes, you know this. Weight, and it is normal force. This normal force is nothing but electromagnetic force between charged particles of this book and hand. Yes, this normal force is neat electromagnetic force between charged particles of our hand and the book at the surface in contact. And as this electromagnetic force is stronger compared to gravitational force, it balances the gravitational force. Clear about this? Okay, so if you say okay, yes, there is no this electromagnetic force, if electromagnetic force is weaker, then what happens? Okay, if electromagnetic force were not so much stronger than gravitational force, we ourselves would crumble under our own weight. Yes, if you put book in your hand, then yes, your hand will crumble under the weight of this book. If electromagnetic force were not stronger than gravitational force. Clear? So yes, if you know the concept of tension, okay, what is tension? Okay, then another forces, interatomic forces. These all forces are nothing but this normal force also. Okay, this normal force. They are nothing but they are electromagnetic forces. Clear about this? Clear about this? Okay, so yes, it is about electromagnetic force. Two forces, gravitational force, electromagnetic force. You have to remember this all points. Clear about this? Okay, now we will see next two forces. First of all, write down this form. Okay, next force, third force is strong nuclear force. Strong nuclear force. Why it is named nuclear force? Because this force is acting only in nucleus. This force is acting in nucleus. Okay. Yes. Strong nuclear force. It binds protons and neutrons in a nucleus. How? See, we know the model of atom. Okay, in a nucleus, there are protons and neutrons. There are protons and neutrons. Yes, proton is positively charged, but charge on neutron is 0, means it is chargeless. So if in a nucleus there are some more protons and neutrons, okay, then obviously there is repulsive force. There is repulsive force, repulsive electric force, repulsive electric force between protons. Now what do you mean by repulsive force? Repulsive force means they will move away due to each other. They will move away due to each other. Yes. Neutron, they are chargeless, okay, means there is no electric force between them. Why do you not consider gravitational force? Because gravitational force is much weaker than electromagnetic force. So yes, here in a nucleus, proton, neutron, proton positively charged particles, so there is electrical repulsive force between them. Then why they are held in very tiny region? Okay, see, strong nuclear force binds proton and neutron in nucleus. That is strong nuclear force that binds this. Okay, without some attractive force, nucleus will be unstable due to electric repulsive between two protons. This attractive force cannot be gravitational force, because gravitational force is very weaker than electric force. So a new basic force must be evolved, and this new basic force is nothing but strong nuclear force. Strong nuclear force. Okay, so yes, strong nuclear force is attractive force which is greater than electromagnetic force. Due to electromagnetic force, proton and proton, repulsive force, they will move away. But there is strong force, that is strong nuclear force, okay, due to which protons, they lie in very tiny region called nucleus. Okay, so yes, strong nuclear force is strongest of all fundamental forces. Strong nuclear force is strongest of all fundamental forces. It is about 100 times the electromagnetic force in strength. Electromagnetic force is stronger than gravitational force, but strong nuclear force is greater than all forces. Okay, all fundamental forces. It is charge independent force. Charge independent force means, see, this electric repulsive force is acting between protons, means charged particles. But this strong nuclear force acts between proton and proton, proton and neutron, and also between two neutrons. So from this, obviously, it is charge independent, because it acts equally between proton, neutron, and proton and neutron. That's why proton and neutron, they are called nucleons. They are called nucleons. Okay, so remember this point. This about this strong nuclear force we will study in 12th chapter number 13. 12th chapter number 13. Chapter itself is Nucleus. Okay, so yes, it acts equally between proton, neutron, and proton and neutron. Range of this force is 10 raised to minus 15 meter. It means 10 raised to minus 15 meter. It means it is short range force. It is short range force because it acts only in nucleus. It acts only inside nucleus. So yes, this strong nuclear force is short range force, and its range is 10 raised to minus 15 meter. That is nothing but size of nucleus. It is nothing but size of nucleus. Okay, so yes, this point you have to remember. Next point is, it is responsible for stability of nucleus. Yes, it is responsible for stability of nucleus. Yes, in light elements inside nucleus, there are less numbers of protons and neutrons. But in heavy nucleus, there are more numbers of proton and neutron. Then how in tiny region they are held? Okay, they are held, they are bind in a nucleus. So due to strong nuclear force, electron does not experience this force. Yes, electron does not experience this strong nuclear force. Clear? So yes, it is data about, it is information about strong nuclear force. Again, we will see this topic in detail in 12th. Okay. Yes, you have to remember these all points. Next one, weak nuclear force. What is weak nuclear force? Okay, see, it appears only in certain nuclear processes like beta decay. Now, new question. Sir, weak nuclear force, it is new for us. And also this nuclear process, beta decay, hey, what is this? Okay, again in 12th, in chapter number 30, that is nucleus, you will study there are some nuclear processes. Okay, due to disintegration of nucleus, energy is produced, and among with that energy, some particles are emitted. If alpha particles are emitted, it is called alpha decay. If beta particles are emitted, it is called beta decay. If gamma radiation is emitted, it is called gamma decay. You will study, okay? Right now you have to remember these heavy words. Okay, so yes, weak nuclear force, it appears only in certain nuclear processes called beta decay. In beta decay, what happens? Nucleus, due to disintegration of nucleus, it emits electron and neutrino. Now, how it emits electron and neutrino? Okay, there are some questions. Okay, sir, beta decay, nucleus disintegrates, it emits electron and neutrino. How? Inside nucleus though there are proton and neutron, then how it emits electron and neutrino? So much confusion, है ना? Yes, confusion. Okay, but we will study in 12. Okay, right now you have to remember these points only. Next point, weak nuclear force is not as weak as gravity, but much weaker than the strong nuclear force and electromagnetic force. Means this weak nuclear force is stronger than gravity. Yes, it is stronger than gravity. Its range 10 raised to minus 16 meters. That is smaller than size of nucleus. Clear? So yes, it is about weak nuclear force. Again, okay, hello, about this all four fundamental forces you will study. Don't worry about this, okay, we will study in detail. But in this first chapter, okay, that is one introductory chapter, you have to remember these all four forces. Another topic of this book, of this chapter, are what is scope of physics, okay, then what is future, etc., etc. That is given, that is not important, because this chapter is all about questions. It is all about observations, okay, this happens. Do you have any observations? This happens. Do you have any idea? Okay, so it is all about questions, it is all about observations. And in 11th and 12th, we will find answers of that questions. Okay, so yes, it is about four forces. Last, there is one table. Okay, so yes, we can say it is conclusion. It is conclusion, or it is comparison among four fundamental forces. Gravitational force, weak nuclear force, electromagnetic force, strong nuclear force. Strength increases. Okay, we will see the relative strength with respect to strong nuclear force. It is strongest. Okay, then electromagnetic force 10 raised to minus 2. Then weak nuclear force 10 raised to minus 13. It is 10 raised to minus 13. Now, with respect to strong nuclear force, I can say, okay, strong nuclear force is stronger than electromagnetic force by 10 raised to 2, means 100 times. By weak nuclear force 10 raised to 13 times. By gravitational force by 10 raised to 38 times. Or in other words, gravitational force is weaker by 10 raised to minus 38 times than strong nuclear force. Words came, okay? Yes, you can easily understand. Then you are given range. Okay, gravitational force is acting up to infinite distance, means long range force. Weak nuclear force 10 raised to minus 16 meter, short range force. Electromagnetic force infinite, long range force. And strong nuclear force, that is 10 raised to minus 15 meter, size of nucleus, again short range force. Now these forces are acting between, operates between gravitational force, all object in universe. Remember one statement, Remember one statement, it is universal force. It is universal force. Then weak nuclear force, it is acting only between elementary particles, electron, neutrino. Okay, then electromagnetic force, again it is acting between charged particles. Electromagnetic force is acting between charged particles. Strong nuclear force, it is acting between nucleons. Nucleon means proton and neutron. Nucleons means proton and neutron. Okay, so yes, it is all about fundamental forces in nature. Okay, why they are called fundamental? Because they governs most of phenomena. Okay, for terrestrial objects as well as for microscopic quantities. Clear about this? So yes, from chapter number 1, this is it. Okay, you have to remember these 4 forces only in detail. But this is it for today, and this is it for chapter 1, and this is it for part 1. This is it.